star of minus t, all right, which is rect of minus t over 2 over t. Right, I just substitute that minus t. So if I draw this, what does this guy look like?
So shifted.
Right, but where's it zeroing? So it's a rectangle. So here's PTX. Here's PTX. What's the actually, do you want, I'm just going to write this formula here. I'm going to let you guys do this and then we'll come around. Oh no, I'll just do it. I'll just do it on the board here. PTX, where is it zero? Where what are the two? What are these points? Which one?
0 and t.
Yeah, perfect. Because you see this one is from minus t over 2 to t over 2, and then just got shifted here, all right, by t over 2, all right? So then PRX, actually it's almost easier instead of getting this formula. Remember, PRX is just the match filter is just flipped, all right, and conjugated, all right? And what's the height? Height in both cases is 1. Like that. Okay. Did that camera catch that?
Yeah.
It did? On the bottom there? Okay. There's some people over there. Okay. So PRX in A is the receiver causal. No, because the impulse response has less. So you think, well, I can't even implement this filter, all right? All right. So, okay, so now. Okay. I want to use a variant of the match filter here, all right? Assume PRX is P is okay. Is this filter causal? Yes.
Sorry, just for Dave, did you say causal or non-causal?
Oh, yeah. No.
And why?
Because it's PRX of t is negative for values t less than 0.
Okay.
Right. Is okay. So I'm going to take this and we're going to just delay this. All right. This is actually what happens in most practical systems. All right. All right. So is this filter causal? Okay. Is this filter causal?
Yes.
Yes, it is. Yes, because if I actually drew it, it looks like this.
Professor,
Yeah.
why can't you just delay it? If you just delay it, it won't be matched anymore.
Right. It's not going to be matched, but we'll look what happens. It'll still be fine. All right. It's not. This is no longer matched. Correct. Right. Okay. This is not a match filter, but it's not matched. But it's not the match filter. But it turns out it'll actually do our purpose perfectly well. And this is almost always what happens. They never match it because reality is one of these is usually what the transmitter is causal, so it's always going to have an impulse response that's greater. But if I can never actually create the match filter because if I try to run the match filter, it'll be anti-causal. All right, so it'll never be yes.
Why is it not causal? Because since
PRX of t is not equal to 0 for t less than 0. Okay. Okay. Now, suppose that, S of t is, PRX convolved with R of t. So basically, I'm going to have no channel impairments. I run this through the receiver, and then I sample it this. What is R of t? What is R of n in terms of S of n? All right. So this time, it's actually better to do this. Not use the. You can either have the. You can either use the frequency domain expression or the time domain expression. All right. In this case, we're going to just use the time domain expression. All right. In the time domain expression, you can write that. Remember that R of n. Let's just review this as a general, the general matter here. All right. This will be. Okay. So this one here will be PRX. So let's just look at V of t first of all. V of t is PRX of t convolved with R of t, all right? But this guy here is, this is kind of messy. You should just actually, you can kind of intuitively see here. Oh, then you know what, I'll just directly do it like this, all right? So that's just going to be integral of R of t times, R of, let's write like this, P Rx of u times R of t minus u du, right? Let's just directly write like this, right? So this guy here will be integral, but this guy here is just like this function, it's just 0 to t times R of t minus u du. Is that what by that? Because that's just a p of this. Okay? But R of t, so V R of n, let's write it here. The time domain ones are always kind of worse. You don't need a better way to do this. R of n is integral is integral. I just substitute t here, which would be R of n t, like that. Right? Now, R of t is equal to S of t, so this guy here. Okay. Now this guy here is the sum, and the only tricky thing you have to do here is that you have to remember that I'm already using n as the index, so I have to sum over k. Right? Right. And remember S of nt is p of t of nt. Does that make sense, everyone? I just substituted this. This is too messy to do, probably, for, I mean, if you guys get, actually, does anyone have an intuition before I go off the map? What's the intuition here? What would happen? Is it actually very much simpler? I'm going to go through all the math, but what do you get for Rn in terms of Sn here?
Is it just delayed?
Yeah, it's just going to delay it. Because you're going to get R of n is equal to S of n minus 1. That's all that's going to happen. The reason is that if you ran the match filter, you would have got R of n equal to S of n. But now I'm just running the thing at one simple delay, so I'm just going to get R of n equals S of n minus 1. That's the short answer of this, right? Well, actually, with a gain, there's a gain related here because these weren't orthogonal. These weren't normalized, all right? There'll be a gain of like, I think, t squared or something like that, or t. All right. So it'll look like this, all right? So this guy here, all right, so this one here, if you look at this will be, now, remember here that P of T, PTX of T looks like this, from 0 to T. So PTX of n minus k times T minus U, all right? That will look like, look like this guy. When U is equal to n minus k, from n minus k and then I think it'll look like this. I think that's right. So it'll look like this. It will look like this guy shifting here. Because when U is this mind blown up the other way. It'll look like. Okay, so it'll look like this. This is too much to do. I think that this is too much labor here. All right, so if I look at this guy here, all right, now, so that's what this guy looks like. I multiply it, I integrate this from 0 to t. This will only be 1. Okay, so if I integrate this from 0 to t of this,